Okay, so today we're going to be looking at simplifying polynomial expressions. So we're taking everything we've learned and we're putting it all together. So what do you notice about this question? What do we have in this question, in this expression? Yep.
We have brackets as well as left sign.
Yeah. So we do have brackets. Can I simplify what's inside the bracket? Can I add 1 to 3x? Are they like terms? No. So I can't simplify inside the brackets. Same thing, I can't take 4 away from an unknown. I don't know what x is. So we want to expand and get rid of the brackets. What have you learned about simplifying and expanding when we have brackets? What do we do whenever we have a bracket? We know that we have to, a bracket means multiplication, so I need to multiply the term outside the bracket by every term inside the bracket. We're distributing 2. 2 needs to be multiplied by 3x, and 2 needs to be multiplied by positive 1. Okay, so we'll start with expanding. Well, what's 2 times 3x? What's 2 times 3x? 6x, good. And what's 2 times positive 1? Positive 2, good. Okay, what is 3 multiplied, right? Because again, brackets means multiply. 3 times x, positive 3 times x. Katie?
3x.
Positive 3x, good. And then what's the next thing I need to multiply together? Yes?
3 times -4.
Good. 3, oops, I'll use purple. Positive 3 times -4. We need to distribute this 3 by everything. So positive and a negative gives us a negative 12. So we've expanded this. First step is to remove the brackets. Now what? Now what do I need to do? Sally? How do I simplify? What do I have to do to simplify? Good. Combine your like terms, and I already color-coded these. So which term can go with 6x? Positive 3x, good. So I know I'm going to combine 6x and 3x because they both have just the variable x. And then I have positive 2 and a negative 12. Both of these terms are constant terms. They don't have a variable, so I'm going to combine these together. Okay, so now that we've grouped our like terms together, let's simplify it. What's 6x plus 3x? 9x. And what's 2? Take away 12. Negative 10. Okay, so we want to use the distributive property to expand the products, to get rid of the brackets. So the first thing we have is 3x squared, and we need to distribute it to each term. So we're going to multiply the coefficients first. What's 3 times 4? 12. Then we need to apply the exponent principles, the exponent law. Well, what's x to the power of 2 times x to the power of 3? X to the power of 5, good. We add the exponents because they have the same base. What's the next thing I need to multiply? 3x squared times negative 2x squared, good. Again, coefficients. 3 times a negative 2, negative 6. X squared times x squared, x to the power of 4, good. Finally, last term inside the bracket, we're going to multiply 3x squared times 6x. Let's just put to the power of, what exponent can I put there? 1. Okay, just so that we remember to add the 1. So 3 times 6, positive 18. X squared times x to the power of 1 is x to the power of 3. Good. Okay, for the next part, we have a negative sign in front of the bracket. So we have to multiply each term by negative 1, right? Negative 1 times positive x to the power of 5 is negative x to the power of 5, good. negative times a positive, negative, and the term stays the same because it's just being multiplied by 1. Negative times a negative is positive 4x cubed. What do I do with this plus 7x to the power 5? We just write it in. Nothing is distributed to this because it's outside the bracket, so that just stays as is. How many of you had the first line correct? Okay, now we need to just figure out which terms are alike and group them all together. So we'll start with the first term. Are there any other terms that have x to the power of 5? Where? Good, negative x to the power of 5, and good. So let's rewrite those. 12x to the power of 5 minus, I'm going to put a 1 here, 1x to the power of 5 plus 7x to the power of 5. Okay, next term is negative 6x to the power of 4. Any other x to the power of 4 terms? Good. So negative 6x to the power of 4 minus 5x to the power of 4. And then what's my last term? Positive 18x to the power of 3. And this term goes with it because it also has x to the power of 3. So we do have 3 different types of terms, right? 3 unlike terms. So let's just simplify this now. What's 12? Take away 1 plus 7. Positive 18 x to the power of 5. Negative 6 take away 5. Negative 11 x to the power of 4. And then 18 plus 4. Positive 22 x to the power of 3. And we'll just check. Did I do something wrong? No. Let's just check. We have our last terms. We have an x to the power of 5 term, an x to the power of 4 term, and an x to the power of 3 term. Are they all unlike? Yeah, so we know we can't go any further.
Made with Doodlecast Pro.